Hey guys, BuildZoid here, and today we're going to be taking a look at another DDR5-8000 setup with Ryzen 9000. This time we're on an MSI X870 Tomahawk Wi-Fi motherboard, which was provided by MSI, so big thank you to them for sending over the board for testing. The memory kit that I'm using is a G.skill Trident Z5 RGB Neo 2x16GB 8000 CL38 EXPO memory kit. Which uses Hynix 16 gigabit A die memory chips. That was sent over by G.skill, so big thank you to them for the memory. And the CPU I'm using is a Ryzen 7 9700X that you've seen in some of the past videos. Also, if you'd like to support the content that I make, there are links in the description that you could check out, and that would be much appreciated. And with that out of the way, let's continue. So, as you can see, I do have a fan installed for cooling the memory. Probably not actually necessary for this setup because I'm not running any particularly high voltages and the memory sticks ran very cool. But at the same time, I'd say like with it doesn't like having the fan doesn't hurt anything, and so I'd say generally if you're going to be pushing DDR5, you should probably have a fan pointed at it. And also, like, I'm on a test bench, so I don't have to deal with, like, high ambient air temperatures that you get inside a case with a GPU, right? This is an open air test bench, so the memory is getting, like, as fresh air as basically possible. Um, so, yeah. Anyway, if you're wondering how that fan is installed, that's like this. I just have some very tall standoffs, and I believe 80mm fans just fit directly onto that. So, yep. If you want to copy this, this is a really convenient way of attaching fans to motherboards, well, above the memory. Um, anyway, you'll notice I also have a picture of one of the G.skill memory sticks here. The reason I have this is because with G.skill memory kits, you can actually tell what memory chips are used by just looking at the label because of this number right here. So this number, and I'm not sure how exactly the full decoding works, but with this stick, we can see that the last letter is an A, and that tells us this is A die. And I'm not sure, like, as far as I know, you can actually tell from this number if it's like Hynix or Samsung or Micron, but I don't know how to do that. But that doesn't really matter because at 8000 CL38, there's basically one memory chip that it could be, which is 16 gigabit A die, which is what it is. So, anyway, but if you were wondering, yeah, with G.skill memory kits, you can actually figure out what memory chips are used by just looking at that number, and you might have to look up like a decoding guide somewhere on the internet. Anyway, back to the system, and now we're going to be taking a look at the stress tests and the stability. So, well, the stress tests and like how things ran. So I will say this was really easy to set up. I've not had, like, I have a bunch of other 16 gigabit Hynix A die memory sticks, but I've not had much success with running them at DDR5-8000 with Ryzen CPUs. However, I also haven't, this 9700X is a relatively new CPU for me. I haven't had it for very long. I've also never used this BIOS version on this motherboard. So basically what I'm getting at is the fact that this, like, the thing is, the EXPO profile on this memory kit does actually just work, which was very surprising to me because, yeah, my experience with a bunch of the other A-die kits that I have is that getting them to work at 8000 is not, I've not really had much success with that, but I also haven't had the CPU, like, I haven't tried it with this CPU very much, and I haven't tried it on this BIOS version, so it could be the memory kit, but it could also be, like, the BIOS version or the CPU. So that is something I'm going to be looking into next is does the Expo profile load up some extra settings, or is the BIOS just more dialed in than it used to be? Because yeah, I was really surprised that like the Expo profile does actually just work. I didn't have to tune any, like I didn't have to tune any voltages. I didn't have to tune any resistances. Nothing. It just works. Which, yeah, I have a really hard time accepting that, but it's true. And so basically the only thing I had to do is tune a bunch of the timings. So this was really easy, and that's kind of cool. But yeah, so do need to, like, I do want to do some more testing on that because that's just like it might be, like, if it's because it's an Expo kit, that's kind of cool. If it's just all A die is now, like, very well supported by this motherboard, that would be even cooler, I guess. But, yeah, so that's the thing is, like, I didn't, like, this wasn't, I didn't really, I don't feel like I did very much here. But yeah, so this was mainly me just tightening the timings. I didn't bother like pushing the cast latency down because pushing the cast latency down is basically just a function of raising the VDD voltage a bunch. And yeah, I don't really think that's very interesting. So I tuned, also the cast latency timing isn't that important from a performance perspective. So I spent most of my time tuning all the other timings. And those are generally quite dialed in. Yeah, I think this is basically as tight as I've run the timings at DDR5-8000, especially considering the fact that I usually use 24 gigabit MDI for DDR5-8000 with Ryzen, and that just inherently doesn't go as tight as ADI does. So, yeah, this is kind of peak performance, or like approaching peak performance for what you can do with 2-to-1 mode with Ryzen. Anyway, in terms of the tests, 16 hours of Karhu, absolutely no errors. Also with the CPU cache test enabled. 3 hours of Y-Cruncher, and then 10 hours of Prime 95. I will point out that I did actually briefly experiment with like very low cast latency. Like I think I tried CL32 or something silly like that. And that actually passed both Y-Cruncher and like 8 hours of Karhu, but it was not happy with Prime 95 large FFTs. So that's why, like, I've decided to include, like, yeah, going forward, I'm going to include Prime 95 large FFTs as one of my tests, because it does catch things that the other two apparently don't. Oh, I suspect the reason that CL32 setup didn't work is because I didn't give it enough voltage, so probably would have been an easy fix, but when I say not enough voltage, I was already at 1.65 volts, and I wanted to, you know, show you settings that are less, less requiring of a fan above the memory sticks. So, anyway, here we are. Yeah, so that's all the tests that it passed. In terms of hardware info, obviously we got no errors. The memory temperature is maxed out at 39 degrees Celsius, which is really low. Yeah, I didn't think they'd be that low, but at the same time, it's worth noting that the 9700X is just not able to read, or, well, it's not read. It's not, the thing is, as far as I know, the 9700X doesn't have a read bandwidth limitation. It has a write bandwidth limitation, but when you're running a memory stress test, you're reading and writing a lot. So the end result of that is that, yeah, like the 9700X just doesn't run the memory as hot as, say, a 9950X would, and a 9950X wouldn't run the memory as hot as an Intel CPU would, but that's not really relevant because this is Ryzen. So, yeah, so that's kind of, and also it's worth noting that a 9800X 3D has the same bandwidth limitations as a 9700X. So if you're looking at this from like a 9800X 3D perspective, this is actually like more useful than, say, a 9950X from like a how it behaves perspective. So yeah, also I did run the CPU with the power limits raised. So you'll see that the max power consumption during all of this testing was 110 watts. For just the like CPU core power, the overall power was up to like 120 something. And yeah, and that's kind of it for what I want to show you in Windows. And now we're going to go into the BIOS. Yeah, I already have a screenshot, so not too worried about that. This should reboot very quickly. What's kind of interesting is on the latest AGSAs, or actually I'm not sure if it's the AGSA doing this, but on this BIOS version, power down mode is disabled by default, and it doesn't really seem to cause any issues. Now, apparently that bug was fixed ages ago, but I never bothered to retest it, and now that it's disabled by default, it's like, well, whatever. I'll leave it alone. I'm kind of surprised that the motherboard decided to retrain right there. Because it sat on that 15 code for a while. the system will like retrain every, like, I'm not sure. There's like a rule that the memory will get retrained after X number of. I'm not sure if it's reboots or after like a certain amount of time. But yeah, like I set this overclock up like 2 days ago, so it shouldn't be doing that right now. Like I wouldn't expect, like, yeah, I wouldn't expect it to do that right now. Um, but it's probably fine. Because I haven't, like, when I was setting this up, I didn't run into any weirdness. Like, I think I ran through like three or four different configurations, and the behavior was like there wasn't any scenario where I randomly just had no stability, which is like a real problem with memory tuning sometimes, is that you'll, like, the memory controller will just botch the training and then it won't be stable even though your settings are like perfectly good. And if you're really unlucky, you'll be on some BIOS version where it gets stuck on that, and then it won't work until you clear CMOS. Anyway, so I think we'll start with the voltages. I lowered the SoC voltage all the way down to 1.05 volts because in 2-to-1 mode, the memory controller isn't running at some crazy frequency, so we don't need a lot of SoC voltage. And running low SoC voltage reduces the CPU's idle power consumption and frees up some of the power budget as well if you're power limited. So yeah, this is probably one of the biggest well, this is one of the like either benefits that 2-to-1 mode has, other than the fact that you can actually synchronize the Infinity Fabric with the memory controller. Yeah, so which you would have seen in Zen timings, that the memory controller is at 2 gigahertz, and I also have the Infinity Fabric at 2 gigahertz, and this is the optimal configuration for gaming. Because technically, from like a raw bandwidth perspective, yeah, 2200 FCLK would give me more memory bandwidth, but it would desync the Infinity Fabric from the memory controller, so it would have more latency. Which, for games, the latency is kind of the priority. There are some exceptions to that. I think the Spider-Man game is like particularly memory bandwidth heavy, but generally speaking, most games you want lower memory latency, not more memory bandwidth. And yeah, the rest of the voltages, as you can see, I've literally left them on auto because they do actually just work, which is really cool. Yeah, I didn't have to do anything because, and I'm really like, I'm kind of surprised by that. Also, you might be seeing the high voltage mode disabled. It's actually enabled right now. It's just the motherboard doesn't have like an auto option. So when you turn on Expo, and if your Expo profile is 1.45 volts, it turns on high voltage mode automatically. And you'll also VDDIO is at 1.45 volts, which is perfectly fine. That's not going to damage the CPU. If it would, then they wouldn't make Expo profiles like that. Because Expo profiles do actually need to go back by AMD. They do need to get some approval for that. So yeah, it's not like you're going to see an Expo profile that sets your VDDIO to like 1.7 volts. At least not from any like reputable memory vendor, which G.skill definitely is. So yeah, SoC voltage was literally the only thing I tweaked, because by default this motherboard actually sets it to 1.3. Which, especially in like for 1-to-1 mode, I can understand why you would set it to 1.3, but for 2-to-1 mode, that is just utterly pointless, and it just burns a bunch of power. On some CPUs, it actually makes the stability worse. So yeah, there's really no reason for that. So 1.05 volts. Honestly, I could probably run even less SoC voltage than this, but 1.05 is actually the stock. Like I didn't really want to spend a bunch of time minimizing the SoC voltage because it's not like, I don't really consider that a priority, but it could be done. Like there's a decent chance this would still work at like 0.95 volts instead of 1.05. Anyway, VDDG, left that on auto. I haven't really found a reason to mess with that on 9000 series, and I'm pretty sure on this motherboard, on some previous BIOS versions, this was actually broken. Like changing VDDG voltage would stop the board from posting, so yeah, didn't mess with that. And VDDP is also on auto because it does default to 1.05 volts, as you probably... Well, actually, I didn't point that out in Zen timings because I forgot that we wouldn't be able to see it down here. But yeah, this defaults to 1.05 volts on this board, and that's actually a perfectly reasonable voltage. That's sort of what I start with for 2-to-1 mode setups, is 1.05 VDDP. So Though that can vary by motherboard. Like there are some motherboards that like really high VDDP, but with like this CPU and this MSI board, the Asus ITX board, actually even the ATX, like so far I've just been using like 1.05 VDDP, and that's generally worked the best, especially in 2-to-1 mode. In 1-to-1 mode, I'll often actually use even less VDDP, but yeah, for 2-to-1, 1.05 is sort of like it works, so I don't see a reason to change it kind of voltage situation. So anyway, let's take a look at the actual timings. Now, with the latest AGSA, AMD has given us access to the TRCD write register, which controls the delay between an activate command and a write command, whereas TRCD RD controls the delay between an activate command and a read command. And the reason you can set TRCD WR so incredibly low is that when you send an activate command and then you want to read something, the point of the activate command is that you're basically activating the, like I'm grossly simplifying here, but you activate the data that's stored in the memory so that you can read it, right? So if you send an activate command and then you send a read command too quickly, the data won't be activated yet and you'll get sent a bunch of garbage, which is bad because if you get a bunch of garbage instead of the thing you wanted to read, your CPU is going to crash. Now, with TRCDWR, this is not a concern because we're not reading anything in the memory, we're writing over it. We don't care if it's not active yet because we're writing it, right? Like we're just writing, we're going to write over whatever is going to get pulled out, whatever is in the memory. So you can set TRCDWR incredibly low and it's just fine. That's why that works. It's not because the activate command is getting completed faster. It's because we actually don't care if it completes fully or not. It's also worth noting that the write data is only going to be arriving after cast write latency time. And cast write latency right now is like 36 cycles. So we're going to be, like technically you could, like maybe if we were running a really low cast latency, you might, like there might be a scenario where you like write before the memory is even able to accept the data. But in this setup right now, like that, the write data shows up, what is it, 16 plus 36 cycles. So that's like 52 cycles later. Yep. Yeah, that's 52 cycles. So yeah, that's not a concern, right? Like it's still going to show up later than a read command would start. Whereas with a read command, like the data needs to be active in order for the read to work properly. With a write command, we don't care if the data is active or not, because we're writing over it. So also this isn't necessarily minimized. It's also not that important from a performance perspective, sadly, because generally speaking, CPUs are not very write bandwidth limited. Which is why AMD does the thing where the single CCD chips only have half as much write bandwidth because, yeah, generally speaking, write bandwidth is not a performance bottleneck. You generally, like, if you think about a simple math problem like 1 plus, like, say, 5 plus 4 equals 9, right? You have two inputs and one output. You have the 5 and the 4, which you would need to read, and then you have the 9 output. And also, the plus is like an instruction. You'd have to read that as well. So you're doing a lot of reading to get like one number, right? So generally speaking, write bandwidth and write latency is not a priority, and consequently, TRCDWR, while it does help, it doesn't help that much most of the time. So yeah, you could probably set it lower. Like I would expect that even like 12 or 10 might work, maybe even 8. I think the register limit is 8. Yeah, that is the actual register limit. 16 was just like a number that I was like, yeah, that's definitely going to work, so I'm just going to set it to 16. And yeah, it does work. Yeah, so that's like a fun thing that you can do, I guess. It's just not really, it's not that important. It's also not really new. On AM4, this was a possibility, so it's new to AM5. And you can also do it on Intel 13th gen and 14th gen, which is the other reason that I just went to 16, because I already know that 16 works on like 13th gen Intel CPUs and 14th gen Intel CPUs with Hynix 8i sticks. So this was like a very safe option for TRCDWR value. It could probably go lower. At a minimum, I'd really expect 12 should work because of that whole, like, oh, well, cast write latency, right? It still works out to be more than TRC DRD. So anyway, so that's TRC DWR. You can set it stupid low. It'll slightly improve write performance, which unfortunately isn't that important. TRC-DRD, on the other hand, this actually is kind of, from a performance perspective, pretty important. Unfortunately, you can't cheat on it like you can with TRC-DWR. So yeah, this is just kind of limited to whatever the memory sticks do. Now, there's a chance that 45 would have worked instead of 46, but I didn't want to spend, like, setting TRC-DRD too low will sometimes give you errors that show up really late in testing, and I didn't want to have to deal with that because I do have a ton of testing to do. G.skill sent 3 memory kits. This is the first video that I'm doing with one of them. So, yeah. So, yeah, I didn't want to, like, spend a bunch of time fiddling with something like TRC-DRD because lowering it one more tick to 45 might work. It'll be slightly faster, not really noticeably faster. So 46 is, in my opinion, a much, like, safer option. And also still technically lower than the EXPO profile. Now, TRP I just set to 38 because that's the, like, with Hynix 8i, you can generally just assume that TRP is probably going to work equal to TCL or, like, 2 ticks above. It does vary by kit. Like, some kits actually have really bad TRP limits. But a lot of the time, just setting it equal to cast latency does work. So cast latency, and admittedly, this 38 is the EXPO profile of this kit. I didn't check if 36 works. If it doesn't, then you could fix it with just a little bit more voltage. Yeah, I didn't want to, like, spend a bunch of time on that, so just set TRP to 38 because that's what the cast latency is, and that does work. So yeah, then TRAS to 48, kind of similar story to the TRP. When you're in 2-to-1 mode at DDR5-8000, you might actually hit a TRC limit with a lot of Hynix sticks. Both, well, with M-die, that TRC limit tends to be higher than it is on A-die. But yeah, you're probably going to hit a TRC limit at some point, and I didn't really want to run into that because it can be kind of annoying to fix. So I just went with a rather kind of safe, boring option of setting TRAS to 48, which I don't think there's any chance that that would not work. And then TRC to 86, because 86 is 38 plus 48. At least it probably is, because I don't have that much confidence in my math skills. TWR is at 48, which is the register limit. You can't set it any lower than that. TRFC1 is at 480. This is generally about as low as you can set it for A-die at 8000. Well, you can probably also try, like, 470, but I tried 464 and that doesn't work. That's too low. So, yeah, this is pretty close to minimized. If you want to be lazy with it, you could just set it to, like, 512 or something, and that's not really, like, that's not really going to affect the performance, and it's going to completely make it impossible that your TRFC is unstable. Refresh interval, 65,000, maxed out. If you don't have very good memory cooling, you might want to run this at 50,000 instead. But like I showed earlier, like, the memory here was running at, like, 39 degrees Celsius. So I could have probably gotten away with not having the fan on there, and that 65,000 refresh interval would have probably still worked. Because this should work all the way up to, like, 50-ish, maybe 55 degrees Celsius. And we're, like, miles away from that. Anyway, RTP at 12. This might actually go a bit lower. It's just not that important. Then the TRDs I have at 8832. For 2-to-1 mode, I don't believe you can actually, like, well, you can set them lower than this, but as far as I know, it doesn't actually do anything to set them any below 8. So, yeah, I just set them to 8832. The TFAW is set to the 32 because that's 4 times the short TRD. So that's TRRD-S. The S stands for short. Anyway, then we have WTRL, which I have set to 16, WTRS, which is set to 2. These are basically minimized. They're not going to, like, they really probably won't go any lower than this. And then we have the back-to-back timings, where I have read-to-read, like, back-to-back read on 8, back-to-back write 8, and this is for the same bank group. Also, well, I guess that's the Expo profile doing that. The SC timings are at 1. On some kits, you might find that you have to set these to 1 manually because some other boards will sometimes default it to 2. I don't think that should ever happen with an Expo memory kit, but yeah, I've seen that happen with XMP kits where those will get set to 2 instead of 1, and that's bad. Really bad. Like, that absolutely nukes your memory bandwidth. Anyway, TWRRD I have set to 4, and RDWR set to 18. I think this might sometimes be able to go lower, but this is basically minimized. I would not expect that to go any lower than that. Power down mode is actually disabled by default, as I mentioned earlier. Actually, we'll just go into Windows at this point, because we've gone through all of the settings I actually bothered to set. Oh, yeah. If you're wondering why these two are on auto, they don't do anything, so you don't have to worry about configuring them. Yeah, but the rest of the settings here in the memory settings, I didn't have to set any of these. It's just really nice. Like, that's kind of the whole point of, like, like, to me, that is just the motherboard BIOS, like, the motherboard, the BIOS, the AGSA, everything is working properly, right? It's kind of the whole point of an 8000 EXPO, is that it does just, like, the frequency just works. Because the thing is, a lot of these settings down here, these are not, like, memory timings for improving performance. These are all basically, like, signal quality settings. And if the motherboard is set up correctly, it should have them set correctly, right? So you should, like, basically, if you have to mess with these, it means that the motherboard's own, like, setting, like, the motherboard isn't properly tuned for its own memory topology, basically. So, yeah. So I didn't really have to change anything else, which is kind of cool. Oh, I did disable TSME, but I believe that is actually disabled by default as well. There's just no way to check that one from Windows, at least that I'm aware of. So anyway, let's go back into the OS, and I'm going to just pull up Zen timings one more time to, you know, show some of the stuff that the BIOS doesn't show. Also, I just remembered that I forgot to mention the Phi RDL timings, which unfortunately they're not matching, and I'm not aware of a way to fix that. So yeah, so this timing down here, T-Phi RDL, that's at 38 for one of the channels, and the other is at 40. So in 1-to-1 mode, they'll generally match, in my experience. In 2-to-1 mode, they generally don't. I am not aware of a way of forcing them to be the same. And I believe that the reason that they end up mismatched is because of the physical differences between the two memory channels. But I could be wrong about that. Anyway, the other thing I wanted to show is that CLDO VDDP is defaulted to 1.05 volts. You might be like, but that's not 1.05, that's 1.0478. Yeah, and that's what you get when you set it to 1.05. Based on past experiences with this motherboard, it's just, yeah. Anything else? Oh yeah, and then you can see that, like, power down mode is disabled down here. So yeah. That's, like, some better timings for this G.skill EXPO kit on this motherboard. And, like, I gotta say, I'm still so surprised that it just worked. This is literally the most pain-free DDR5-8000 experience I've ever had. And the first time I've got an A die to work at DDR5-8000. Because, like, I've not had A die, like, so far every time I did DDR5-8000, I was using 24 gigabit M die. And then, you know, admittedly, I haven't tried the other kits that I have with this BIOS version, but I'm very, very impressed with how well this worked. I might also test if my Potato 9950X, like, is, like, magically fixed with this memory kit. I have my doubts, but That would be kind of cool if, like, it was actually just a memory kit issue or something, or a BIOS version issue. I still haven't, figured out for sure what exactly was causing the problem. Um, but yeah, so you know what? I might actually leave the timings up. So, I mean, there's a text version of the timings on Patreon. So, but you can also just copy them from the video, I guess. Oh, why that wasn't my intention. Ugh. Anyway, that's it for the video. Um, and like I know it sounds like I'm surprised that Expo worked. I don't expect these things to work this well. Um, yeah. Big thank you to G.skill and MSI for the motherboard and the memory kit. And that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. And if you'd like to support what I do here with the channel, there's a bunch of links in the description that you could check out, and that would be very much appreciated. So yeah, that's it. Thanks for watching, and goodbye.